All right, scholars. So right now I'm going over part one of the middle of the year study guide. Now, this is for students that are either on the fifth grade level, like late fifth grade on iReady, or early sixth grade on iReady. Um, this is a way to like help move them into like mid I mid sixth grade to late sixth grade. This is not all of the information for late sixth grade. When you do the end of the year, my goal is to provide resources for the end of the year, but this is for those students that are late fifth grade, early sixth grade, or mid sixth grade to review. What I've noticed is that a lot of students struggle with geometry because it's not something that, well, geometry with like nets and 3D figures. And this is a way for students to have like a solid or like a fundamental understanding of how everything works. So I'll try my best to take it slow, but also like just give a refresher or like a update based on your where you are in iReady. So let's start off. Like, what is a net, right? A net of a shape, also called a geometry net, is a term used to describe what a 3D shape would look like if it was opened out and laid flat. For example, this is a solid net of a pyramid. This is a solid pyramid, right? However, the net is if I laid all of the pieces flat, right? This is what it will look like. Same here. This is the net of a cone. This is the net. This is the cone, and this is the net of the cone, right? If it was laid out flat. Cylinder. This is the net of a cylinder if it was all laid out flat, and net of a rectangular prism if it is laid out flat. All right. So, of course, this is a three-dimensional shape, and this is its net, right? When you're finding the area of the net, it will be in 2D as opposed to finding the volume of the prism or cylinder, it would be in 3D, right? So let's look at this. This is the net of a rectangular prism. This is the net of a pyramid. In a net, it has faces. Faces show like when it's laid flat. So if you look at this 3D shape, if we found the net of this 3D shape, it'll have one, two, three, four, five, six faces, right? And as you can see, if you were building a rectangular prism, this is the layout of what that rectangular prism will be. And if you connected the vertices together or the sides together and it closed, this is what it will look like. Same with the cylinder, same with the pyramid, same with the cone. So right now, I want to show you what this looks like, okay? So this is a cube. What I love about talking about a cube is that literally all sides are the same. A cube has six faces of six squares, which means the length and the width of all of the faces are the same. So if you're connecting it, you know that this is a cube. Now, what is the net of the cube, right? The net of the cube would be this right here. You see, these are all squares and they all have the same length and width. So as you can see, the 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 cube, right? The volume of a cube, when flattened out, it creates the net. All right. Now, let's look at this one. This is what you call a triangular pyramid, which means that all of the faces would show triangles, right? So this is a triangular pyramid, and the net of the triangle pyramid, sorry, not that, would be this, right? All triangles connected together to create a triangular pyramid. So please excuse this. That doesn't matter. That's not that. That's this right here. All right. Rectangular prism, right? This is a rectangular prism because it has rectangular faces. And when we find the net of the rectangular prism, it would look like this up here. Okay? This is what you call a cylinder. This is the cylinder, this is the net. So I'm sure you can determine already what is the net of the cylinder, right? So you would connect here, this is a cylinder, and this is the net of the cylinder. Um, this is a square-based pyramid. You see how it looks like a pyramid, but it has a square at the base. So you would connect this line all the way up to here. And the net of the square-based uh, pyramid would be actually this right here. You see how it is a pyramid because it has pyramid faces. However, at the base, it is a square. Anything else? Oh, then we have the triangular prism. This is what you call a triangular prism, and the net of the triangular prism would have rectangular faces with the connecting points as a triangle. Okay, so hopefully that really helped you understand it. If I can zoom in, so let me do that one more time. This is the cube, right? When the cube's net looks like this, all faces are squares. This is a triangular prism. The triangular prism net is all triangles, even a triangle at the base, etc., etc. So, in today's lesson, we're going to be focusing on a polyhedra, right? So, what is a polyhedra, right? A polyhedra is a 3D figure, and you want to write these notes so that you can remember it. A 3D figure with flat surfaces, straight edges, sorry, and vertices. The surfaces of faces of a polyhedra or polyhedron have to be polygons. So, like, what does that mean, right? And we'll get to this information in a second, but before I want to just explain, like, what does that mean, right? So, I'm going to show you some polygons, right? Where the sides connect with line segments. So, for example, a triangle. Triangle is a polygon because all of the sides connect, right? A square or a rectangle or like a octagon Okay? So like non-polygons would be like circles or like line segments that don't connect. Do you see this space? It doesn't connect. Or 3D figures, right? 3D figures cannot be polygons because they're 3D, right? Now, that's where we go into polyhedra. As we said, polyhedra could be like a square-based pyramid, cubes, rectangular pyramids, triangular prisms. Now, what a polyhedra is not is a cylinder. Do you see you have at the surface, it is a circle. So there are no connected vertices. Okay. So like poly polyhedra are 3D figures with flat surfaces. You see that's a flat surface. Uh, please forgive my drawing, but I'm gonna try. Right? So like a square-based pyramid. Sorry, square-based pyramid. You see how like at the base is a square and all of it connects through with triangle. But a polyhedra is not, it's like a cylinder or anything or a sphere. These are not polyhedra. Okay? So polyhedra can be thought as three-dimensional analog of polygons. Here are some important aspects of polygons. They are made out of line segments, as I shown, called edges. Edges meet at a vertice. For example, this is a vertice, this is a vertice, this is a vertice. So a triangle has three vertices. The edges only meet at vertices. Polygons always enclose a two-dimensional region. For example, a circle could not be a polygon or like uh, a line segment that doesn't fully connect, right? So here is an analogous way to categorize a polyhedron. They are made out of filled-in polygons called faces. This is a face, this is a face, this is a face. Rectangular prisms always have six faces because it takes six faces to connect everything at a vertex, right? Polyhedra always encloses a three-dimensional region. Now, students do not need to memorize the formal definition of a polyhedron, but it's really good to help make sense of nets and surface area, right? So the nets is like, as we said, the 3D shape, right? And if it's opened up, like these are nets. However, this is not a polyhedra, and neither is this because it has circles. However, this is a polyhedra because all of the faces are polygons. All right, that's a good start. Let's go to the meat and potatoes. So here, we want to find the volume and surface area of shapes. Now, you will have what you call like a reference sheet with formulas. And the good thing about formulas is that you can like see variables, which is like the length, width, and height, which are like letters to describe solutions or like numbers. Okay? So here is a rectangular prism. It's also a polyhedra. Same thing. Here is a rectangular prism. Here is a triangular prism. This is a cylinder. This is also a cylinder. Or Cylinder. Want to make sure we do that correctly. But this is what we call a cone, right? Some of these are polyhedra, some of these are not. Like these are not polyhedra. These are because they connect at vertices by way of polygons. If you notice, like the top face and the bottom face of this cylinder, is a circle, which is not a polygon, so it's not the same. Same thing with here. They connect with triangles, which are polygons. However, the base of this cone is a circle. So it is not a polyhedron. Now, I am going to use this formula, which is really important, which is on your paper. We can use formulas to find the surface area. Okay? The reason why nets are important is because in order to find the surface area of these, we have to break it apart to find its faces, right? So let's start with the surface area of a rectangular prism, right? So we're going to put surface area of a rectangular now. The surface area of a rectangular prism is the total area of the outside part of a 3D figure. So that is the total area of the outside part of a 3D figure. As I said before, when you're looking at this rectangular prism, it has 6 faces, right? So we have um, the top, the front, the back, the left, the right, the bottom. The top, the bottom, the front, the back, the left, the right. So if I was to create the net of this, we know that the top is smaller than the front and the back. So we have the top, we have front, we have the the left, the right, the back, and the bottom. So we'll say this is the top, or this could be the top, right? Because when it enclosed, right? So this could be the bottom or the top, the bottom. This is the sides. This is the back. And this is I'm sorry, I think this should be the bottom and this could be the front, right? Um, in 6th grade, I would say like it doesn't have to necessarily be like super perfect, but to understand is 1, 2, 3, 4, 5, 6. The net has 6 faces, and when we build it all up together, it would create this rectangular prism. Now, when you're finding the surface area, you got to find things that make sense, right? So we know that the top and the bottom will have the same, which is why the formula would be, so we say the top and the bottom are the same. We know that the left and the right are the same. And we know the front and the back are the same, right? So because it's a rectangular prism, we know to find the area, it's the length times the width. However, you want to put that in parentheses because it's multiplied by 2 because you have the top and the bottom. You have the left and the right, which will have the same length and width. And you have the front and the back, which will have the same length and width, times 2. Now, if you look at this, right, and you look at this, we could determine what the surface area is of all of the faces. So let's look at the front and the back, right? The front has a length, The formula is length times width. And we could substitute the variables L and W for the value. The length is 4, and the width is 3, right? But because the front and the back are similar, it's multiplied by 2. And we can use distributive property to distribute the 2 into the 4 times the 2 into the 3. Or we can multiply the 4 times the 3 and then multiply that by 2, whichever way you understand. 4 times 3 is 12, 12 times 2 is 24. Now, I just found the area of the front and the back. The front and the back faces. Now I need to do the top and the bottom. Now the top looks like this, right? The length of the top will be 3. And the width of the bottom will be 2. Do you see that? But it's 2. So now I'm going to use distributive property to help determine this. 2 times 3 equals 6. And then 2 times 2 is 4. And 6 times 4 is 24. You could also do 3 times 2, which is 6. Sorry. Yeah. 2 times 3 is 6. 2 times 2 is 4. 6. I don't think I can distribute this. I love making mistakes because I want you to see how, like, you want to be able to analyze this. 2 times 4 is 8. 2 times 3 is 6. So I believe you have to solve inside first. So 3 times 2 is 6. 6 times 2 is 12. 3 times 2 is 6. And then times 2. 6 times 2 is 12. Right? And then you have the left and the right. The left is this side and this side. So the length is 4, the width is 3. Times 2, 4 times 3 is 12, times 2 equals 24. Okay, so then you want to add everything up. So you have 24 plus 12 plus 24. And I'm going to do it one more time just to make sure I'm right. So the front and the back is 4 times 3. 4 times 3 is 12. 12 times 2 is 24. The left and the right is 4 times 2, which is 8. 8 times 2 is 16. Left and the right. 4 times 2. That's what I did wrong. 2. 4 times 2 is 8. 8 times 2 is 16. And sometimes you can just look at it and see if something's off. You clearly know the front and the back will be larger than the top and the bottom and the left and the right because it's fuller, right? So then 24 plus 12 plus 16. Okay? 4 plus 2 is 6. 6 plus 6 is 12. 2 plus 1 is 3, plus 1 is 4, plus 2 is 6. So we have 62. I like to do it over again We said that this is 16. 6 plus 2 is 8, 9, 10, 11, 12. Carry the 1, bring down a 2. 2 plus 1 is 3, 4, 2, 52. This is why it's good to have a pencil. But let's just do it one more time because I don't want to teach you anything that you don't really understand or you don't know. This is a net. These are the faces. The front is 3 by 4. 3 by 4 is 12. 12 times 2 is 24. Got that. The top is 3 times 2, which is 6. 6 times 2 is 12. Got that. The left and the right is 4 by 2. See how this is 2? Because it's congruent. 4 times 2 is 8. 8 times 2 is 16. 24 plus 12 is 16. 4 plus 2 is 6. 6 plus 6 is 12. Carry the 1, bring down a 2. 2 plus 1 is 3, 4, and this is a 1, 5. So it's 52 inches, right? And when you're finding the surface area, you know it's squared because area is squared. We figured that out. Now, to solve for something like a cylinder, you got to understand a few things. You know that a cylinder has circles, right? You see that? And you see this line here? This is called a diameter, right? And half of a diameter is the radius, okay? And we know that this symbol right here is pi, like Pi Day. And the pi is measured at 3.14. But as you know, there are so many digits that happen. 3.14569, blah, 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 blah. You know the song. But we usually just use pi as 3.14. Now, let's look at this formula. So we're going to see if we can use substitution to determine the formula of a cylinder. So as we see a cylinder is here, to find the surface area, it's 2 pi r parentheses r plus height. Wow. In process of elimination, you want to solve inside. So let's substitute what is the radius and what is the height. We know the diameter. We know the diameter is 8, right? So the radius is 4. The height here is 11. So far, we're doing well, right? And we know 4 plus 11 is 15. Now, 2 pi and r. So pi is 3.14, and when two variables are connected or a variable is connected to a number, we know it's being multiplied. The radius, as we said, is 4. And then we're going to multiply that by 2. So 3.14 times 4 . 4 times 4 is 16. 4 times 1 is 4, 5. Don't forget your decimal point. 4 times 3 is 12. Then you have to multiply that by 2. 6 times 2 is 12. 2 times 5 is 10, plus 1 is 11. Don't forget your decimal point. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. 25.12, and the unit is centimeters. And that is the surface area of the cylinder. So we just learned a lot. We learned that a diameter is one edge to the other edge of a circle. We know that the radius is half of a diameter. We know that pi is 3.14. And we learned that we can substitute uh, variables to determine our solution or our answer. I didn't answer them all, but because I want you to try to do the same thing, try to use the formula, right? This is the triangular prism. Do we have a triangular prism? Here's a triangular prism right here, right? But a thing to notate is the faces. In this triangular prism, you have two faces of triangles, and we know the area of a triangle is half the base times the height. Everything else is a rectangle. So you find the area of all the faces, make sure you multiply the faces of the triangles by 2, then add them all together to find the surface area. Okay? Hmm. Now, what is this? Hmm. Let's see. This is what you call a hmm, square-based pyramid. I wouldn't say it's a square-based pyramid. Um, hmm. It would just be a pyramid. So this is a pyramid. How do you know that? Well, in our note, this looks the same. It's a pyramid. One of the faces has a square. All of the other faces have triangles. So a pyramid clearly has 1, 2, 3, 4, 5 faces, right? And we have information. So as you know, this is the net, right? We know this is a net. And is made of a square and 4 identical triangles. All measurements are in centimeters. Units matter. I like to say units matter like Black and Hispanic flag. So you want to notate what the unit is because if you, God forbid, you said this was a meter or an inch. Units help us because based on the unit centimeters, we know how big or small this is. So if the net were folded and assembled, what type of polyhedron would it make? Oh, that's simple. If we folded all of this up, it would create, you see that? Well, I was almost there. One face. Yeah, it would create a pyramid. So we would say it would make a pyramid. What is the surface area? Now, I think this will be pretty easy because of the faces. We know we have 1, 2, 3, 4 faces of triangles and one face of a square. Do you agree? Yeah. 4 faces of triangles, one face of a square. Now, surface area is finding the area of each of these um, polygons, right? Which is why this is a polyhedron, and then adding them all together. Information we have, we know the base, we know the height, so I think we can figure this out. So let's do the square. The square is base times height. And then you notice I do my formula first, and then I substitute my variables for a number. Base is 4, height is 4. So the area is 16 centimeters. Now, we have triangles, which is 1/2 of the base times the height. But we have 4. So the base of all of the triangles are 4. The height of all of the triangles are 7. So 4 times 7 is 28, right? But we got to find half, which is 14. However, that's for 1. We have 4. So we just multiply 14 times 4 is 56. So the area of all of the triangles are 56 centimeters. The area of the square is 14. So we have to add our 16. 16 plus 56. 6 plus 6 is 12. 5, 6, 72 centimeters. And it is squared because we're finding the area. Let's go here. This is a little tricky one. Polyhedron P is a cube with a corner removed and relocated to the top. Polyhedron Q is a cube with the same size base as a polyhedron. How do their surface areas compare? Well, let's first look at it, right? If you look at Q, we know it's 6 faces. It is a cube, so all of the length, the width, all of them are the same, right? But something's different about this, right? Something is removed. But let's look at that, right? If I'm looking at the surface area, this surface is technically this covered up. Do you see that? This is a part of this. So even though it's cut out, it's still a part of this. So basically, that cutout piece is further down, but it still exists, if that makes sense. That means this surface can still be connected to this top surface right here. Do you see that? But also, we have another cube on top of that with more surfaces. So I want you to think about this. Which one has a greater surface area? Because technically, this is the same as this, right? It's just removed from the top, but it's still showing down here. So let's look at our answer choices. P's surface area is less than Q's surface area. A lot of people would think that. That is a misconception. However, this surface area is still the surface. Like, if you brought this up, it'll still show all of this together. It's not asking about volume. It's asking about surface area. So you want to write that. Not asking about volume, right? It's asking about surface area, the area, right? So that can't be true. P's surface area is equal to Q's surface area. Well, that might be true if this didn't exist. So that is incorrect. P's surface area is greater than Q's surface area. I mean, I would feel that it is greater because this is a whole nother cube on top of it. Remember, this surface right here is a part, literally could be this filled in. You get what I'm saying? Because it's not talking about volume. So I would say, using process of elimination, I would say that that makes sense. There is not enough information given to compare the surface area. I think that there is enough information, which is why C is correct. Using logic. I hope you wrote down some information about my logic. Maybe that can really help you. And that's all we have. Good luck, and I know you'll do really well because I'm proud of you. And no matter what you do, make sure you get some good sleep. Make sure you get a good breakfast. And make sure you did the work because I promise it will show. Bye, guys. Bye, scholars. Take care.